Hi there. In this video, we're going to be talking about solving a different type of differential equation, one we haven't dealt with solving yet up to this point. And the method that we're going to be using is called the method of separation of variables. But let me first show you an example of the type of these types of differential equations. All right, so an example of a type of differential equation that separation of variables will work on is the logistic equation. The logistic equation is useful for, in particular, modeling the spread of an epidemic, something that's very relevant for us these days, right? So this is a situation where this type of method would be useful. I'm not going to do this in particular, but I'm going to certainly assign something like this in the homework because I think it'll be interesting to solve an epidemic model like this. Okay, but what we'll look at is a simpler example, and then you can take it from there. So up till this point, every differential equation that we've solved is a differential equation that could be put into this form. Every differential equation that we've solved so far could be written in this form. It may not have looked like that at the beginning, but if you use a little algebra, you can put it into this form. Now, one of the things about this differential equation is that it's linear. Okay, and if you forget what that means, go back and look back at the video where we classify differential equations as linear or nonlinear. Okay, but this one is linear. So what we're going to look at today are differential equations that can be written in this form. These are not necessarily linear. If h of y is not a constant, then this is a nonlinear differential equation. So this is not necessarily linear. So we're going to look at how to solve some nonlinear differential equations today. And the method that we're going to use is called the method of variation of parameters. Sorry. The method that we're going to use is called the method of separation of variables. I was thinking of the method we used in the last video. Separation of variables. Now, putting a differential equation into this form is called separation of variables. So this is the type of differential equation that this will work on. And this is the first step, is to get the differential equation into this form. What's special about this form? Well, this guy over here is a function of y, and this guy over here is a function of x. We've separated the y's to be on the left side and the x terms to be on the right side. Okay? Moreover, we're multiplying by y prime here. And if you can get into this form, that's called, that means you've already separated the variables. And the method of separation of variables is going to proceed as follows. And it uses the following observation. All right? So this guy, h of y times y prime, is the derivative of some function. Okay? If you think about how the chain rule works, when we differentiate a function using the chain rule, we have to multiply by y prime on the outside. And so that's what the y prime is coming from. And so that's how we're going to envision this. All right, so in other words, h of y, y prime, is the derivative of some function h of y, okay, where h is the function such that h prime equals little h. The chain rule says that when you differentiate this, you get h prime, which is little h, that's the h of y part, and then the chain rule says you have to multiply by y prime, so that's where this comes from. So this is just using the chain rule, okay? So what that means is that if we want to solve this differential equation, it's just a matter of anti-differentiating both sides, and the antiderivative of the left-hand side is just h of y. Okay, so in other words, if I take that differential equation and anti-differentiate both sides with respect to x, the left-hand side just becomes this function, whatever it might be, hopefully we can find it, h of y. Now, if this function, if we can end up solving this for y, which you can't always do, but you hope that you will, then we will be able to get to the solution of the differential equation. So hopefully, you can write this as y equals, right, some function. Okay, so that's the idea of separation of variables, is getting all the y's on the left and all the x's on the right. All right. Okay, so what I'm going to do is I'm actually going to look at a differential equation we did look at a while ago. We didn't explicitly solve it, but what we did is in that video we looked at, this was the video on slope fields or direction fields. All right, and we looked at this differential equation. Okay. Turns out this is the differential equation of this form. How can I tell? Well, because I just multiply both sides by y, right? Multiply both sides by y, and we see that this is y times y prime equals negative x. And so here's our h of y times y prime equals g of x. So it is of that form. And so we can go ahead and try to use this method of separation of variables. Now, before we do that, I want to take you to what we looked at before when we were looking at slope fields. We actually looked at the slope field for this differential equation, and we saw what the solutions should look like. So let's see if I can find that here. Here we are. Okay, so this is I put the differential equation into here, right over here, right? And then I had this program, which I've linked to on our course webpage, so you can play around with this. It will generate this slope field, all right? And so at every point, we have a different slope, all right, given by that expression. And so we can see what the solutions ought to look like, right? If I wanted to look for, say, the solution that went through the point, say 4, 2, right? Then I'm looking for, let's see, 4, 2. I'm looking for the solution that goes through that point right there. Well, what is that going to look like? Well, it'll be, if you just follow those lines, follow those slopes that we have indicated here, you see that that traces out a circle. So we should get, as an answer to this differential equation, an expression for this circle. So that's what we were expecting to see. Okay? So let's go ahead and take a look at this. So notice I specified an initial condition. All right, so let's look at this differential equation along with, so comma, an initial condition y of, what did I say, y of 4 equals 2. So I'm not only just solving this differential equation, but we're also going to use this initial condition to get an explicit solution here, a specific solution. All right, so the first step is to write it like this, separation of variables. The next step is to try to find this function h of y. And that just means find the antiderivative of this. So I have to think of a function of y whose derivative is this. And if you think a little bit, pause the video and see if you can come up with it. Okay, so hopefully you've done that. You should have come up with this. 1/2 y squared. When I differentiate this with respect to x, that's our differentiation variable, I get y, but then the chain rule says I have to multiply by dy dx, or y prime, and that's where the y prime comes from. When I anti-differentiate the right-hand side, I get, what do I get? I get negative 1/2 x squared plus some constant. Okay, so let's see here. Now, I could solve this for, I could go ahead and solve this for y, but I think there's maybe a more clever thing we could do here. Instead of solving this for y, since I know the solution is a circle, I know that the standard form of a circle is y squared plus x squared equals r squared, right? So why don't we just put it in that form, and then we'll know it's a circle, right? So let's just add 1/2 x squared to both sides, right? We're almost there. We'll just multiply it through by 2. And we have this. That is a formula for a circle, right? Where the radius is, this is supposed to be the radius squared. So can I determine what this constant is? Well, absolutely. I can use this initial condition to find out what the constant is. This is saying that when x is 4, y is 2. So to find the constant, what I'm going to do is plug those values in, right? So let's go over here. So in place of y, I'm going to put a 2. So we have 2 squared. In place of x, I'm going to put a 4. 4 squared equals 2c, right? So what do I get here? I get 4 plus 16, that's 20, equals 2c. So 2c is equal to 20. And I think that does it for us, right? Y squared plus x squared equals 20. This is the equation that describes our solution. Now you could solve this for y if you wanted, but I think writing it like this is totally fine. We see what kind of curve it is. It's the circle. And that's exactly, if I take us back to here, that's exactly the curve that we're seeing here. And you can see, if you were looking on the side, you could see that's exactly the function that I put in at the beginning, right? And so this is separation of variables, okay? And that is all I have for you here. All right, so I'll see you in the next video.